Hello everybody and welcome back to a new video. I am Pat from Pat's Path Predictor, and as you can see right here, we have an enhanced risk issued for tomorrow, as well as a slight risk for day 3, as well as 2 other 15% risk days, so let's go ahead and dive right into this. Alright, so this is the situation we have right here. So, as you can see, from Nebraska to Oklahoma, there's an enhanced risk right here. It includes the cities of Tulsa and Wichita, Kansas right here, so there's that. There's the slight risk that goes from Texas to more Nebraska and Iowa, including Omaha, Lincoln, McCook, Kansas City, Oklahoma City, Norman, Fort Sill, Wichita Falls. Yeah, encompasses population around 7 million right there. So, yeah, nothing to joke around with. And the marginal risk goes from South Dakota to Texas, okay. And it's just the generic thunderstorm area from Texas all the way up to Wisconsin. So, yeah, it's essentially the map. Let's go ahead and look at the tornado threat, because this is where things get interesting. The tornado threat here is at a 10% area, but all that 10% has a hatched area, which means there is a 10% greater probability of EF2 to EF5 tornadoes, which are considered strong tornadoes, to happen within 25 miles of a point right here. So that's what's ranking up this this enhanced risk area, and so is the hail threat right here, as you can see. The hail threat is at 30%, and the whole 30% is in this hatched area, which means there's a 30% risk of a 2-inch in diameter hail or larger within 25 miles of a point. Same with half of the 15% area of parts of Nebraska, Texas, Oklahoma, Kansas. So that's the situation we have. The wind threat's the least threat. It's at 15%. I'm sorry that happened. It's at 15%. It encompasses the slight risk area. So that's essentially all you need to know with the risk-wise right there. Now let's go ahead and dive right into the summary and synopsis. We'll cut out parts of the synopsis just for time's sake, because we have a lot to cover today. But we will talk about what's going to be happening in the region. So here's the summary. There's an enhanced risk of severe thunderstorms from portions of far southeast Nebraska into central eastern Kansas and north central Oklahoma. Summary. Severe thunderstorms capable of all hazards are possible Friday afternoon into Friday night across portions of the southern and central plains into the lower Missouri Valley. Synopsis. While some uncertainty remains regarding the warm sector and mid-level capping, the overall pattern suggests that a couple of focused areas for severe thunderstorms are possible. One area being near the surface low triple points across parts of northern Kansas into southern Nebraska. The second being late afternoon, early evening across the surface dry line from central Kansas to northeast central Oklahoma. Finally, additional storms are likely to develop along eastward, advancing the cold front overnight. Although this activity may be elevated. So these are the risks for portions of southeast Nebraska into Kansas and Oklahoma. Much of the higher quality warm sector will be focused roughly across the eastern half of Oklahoma and Kansas into the far southeast Nebraska, where a southerly low-level flow around 1 kilometers AGL is forecast. This will maintain a moist air mass east of the dry line. Some forecast guides, particularly in the operational North American model, which is what NAMS it really is, maintains rather cool guidance, particularly in the across the warm sector, with cloudiness prevailing through the day. However, this appears to be an outlier compared to most of the other guidance, with the NAM surface high temperatures perhaps 5 degrees to 10 degrees too cool. This resulting in a capping inversion that is likely too strong. Modified forecast soundings for warmer surface temperatures do result in erosion of the cap. Therefore, while some capping may limit the storm coverage, it is anticipated that at least a few supercells will develop in a narrow corridor along the dry line by early afternoon to early evening. So what all that mumbo jumbo is that there is one model, which is the North American model, which is what I've been using to cover the Cape. In fact, in this model, we're actually going to be using the HER, so this is the HER model, but I was using the NAM. But the NAM has it 5 to 10 degrees too cool, and there's going to be this massive inversion, according to the NAM, that will have the cap that'll be too strong for severe development, which, if the cap is too strong, the Cape cannot escape and severe weather cannot develop. So that's for context right there. But this is just one model. The rest of them are in agreement that the cap's going to erode at least at some point. So depending on the next few NAM model runs will depend on basically if the NAM agrees or if there's going to be a conflict of models, which if there's a conflict of models, that's really the worst thing that can happen, because at that point, if there's a conflict of models, you don't know what to expect. You don't really have even more uncertainty of what to expect, because severe weather is already unexpected weather to an extent. We know this happens. We just don't know when it will. So, yeah, if we're seeing a conflict between models, that may be a problem. Then again, if the NAM is correct, that might be the best case scenario. So I wanted to take some time to fully explain this to you guys, if you may. So, okay, where were we? Very steep mid-level lapse rates and longitude hydrographs of a favorably curved low levels indicate sufficient hail potential with these storms. Furthermore, steep low-level lapse rates and moderate 1 to 3 kilometers of cape areas amidst increasing SRH and low-level jet increases during the evening indicate that tornadoes will also be possible. A couple of which may be significant, which is EF2 or more, which that's not a good sign right there. If the rest of the models are correct, that's not a good sign, because we could be seeing some pretty strong tornadoes, and yeah, we don't need to see any more EF4s or anything like that. So, yeah. If there's a tornado that happens, as long as it stays in the middle of nowhere and doesn't affect anyone, that's fine. But if it's going into a town and potentially killing people, that's the worst case scenario. But let's go ahead and dive right into this. Of note, the CAM guidance appears to leave outflow boundary across far southern Kansas associated into Thursday night, early Friday morning, convection shifting east into Missouri. This boundary will extend from west to east, perpendicular to the dry line, and could be a further area of focus for severe thunderstorm development in the late afternoon. The southward extent of the higher risk probabilities uncertain, but generally will decrease with with southward extent across Oklahoma, as stronger ascent will be focused into the north of the influence of the cap will be greater. A second round of convection may develop into the mid to late evening towards the eastward advancing cold front. This activity will be likely elevated and become linear, though some isolated hail threat could continue eastward in Missouri. Portions of northwest Kansas into western and central Nebraska. Strong severe thunderstorms are expected to develop near the deepening surface low across the northwest Kansas by mid-afternoon. Boundary layer moisture will be lower quality compared to further east, with dew points in the 50s to near 60 degrees Fahrenheit. However, very steep mid-level lapse rates will support moderate instability. Effective bulk shear values will support initial supercells capable of large to very large hail. With time, this convection may develop into a bowing line segments as convection shifts northeast into Nebraska. So I want to show you the HRRR now, because this is a perfect opportunity to move to the HRRR. This is the CAPE values for the HRRR model. This is at 23Z, which is 6 p.m. in Central Time. And there are areas in Kansas right here that are cracking 3,000. There's an area in Kansas, Oklahoma, that's cracking close to 4,500 joules per kilogram. So this is just one model right here. But let's actually take a look at the RAP model. Let's take a look at the RAP. So basically, yeah, the RAP doesn't have it as aggressive as before. It does have it at 2,000 to 3,000 joules per kilogram. The NAM, this is the model in question right here. The NAM has the CAPE more concentrated to the south, but then again, we could see that cap. So let's actually move this to Kansas, Oklahoma, Texas. We're seeing a rather big area of 3 to 3,500 joules per kilogram of CAPE right there. The NAMist right here, it's showing something similar. And so I'm noticing that we're seeing an agreement of at least 3,000 joules per kilogram. However, the HRRR is the only one that's going overboard at 4,000. Another thing we need to take a look at is the dew point temperature, because there is a massive dry line that's right behind this, and I want to go to the central Great Plains with this. And pay attention to Kansas and Oklahoma right here. You can see it's going. You just look at these dew points right here. They're in the 60s, in the lower 60s. That dry line starts to advance. It starts sucking all the moisture. That's when those severe storms are what's going to be. That's why there's severe storms there. It's sucking all the moisture. That's what's going on. Okay, the HRRR only goes out that far, but I wanted to show you guys this, because we're seeing some values in Oklahoma up to 64, 65 degrees Fahrenheit. So that's that's generally a good amount of moisture for development right there. So I'll be keeping an eye on it. I want to check the wrap model real quickly because showing it more permits, like I want to show you this. We're seeing 65, 66 dew points right here. Okay, this thing only gets bigger and bigger. Okay, so yeah, we're seeing upper 60s dew points in Nebraska and Missouri right there. Although that won't come into that's risk is that's probably not going to tap into that kind of moisture until the next day. But we'll get into that in just a second. So I wanted to show you guys this because if the temperature, for instance, is 70 degrees, the dew point 67, that's over a 95% humidity, and that kind of moisture is what severe thunderstorms fuel off of, because there's no way there's going to be a severe thunderstorm in dry areas. They don't have enough moisture to suck off of. But yeah, this kind of conducive environment, as well as the Cape on this as well, it's something that we need to keep an eye on, because the Cape in some areas cracks 3,000, sometimes 3,500 in a few models. But yeah, that's essentially day 2 right there. Now, this video is already 11 minutes long, so I'm gonna go ahead and do day 3, and then we'll skim through this quickly, and then we'll get to day 4 and day 5. Yeah, and so let's go ahead and do day 3 because there's not nearly as much information on day 3 as there's more uncertainty. But you can see that slight risk where that 15% area is now a slight risk, and that slight risk has expanded from pretty much from a concentrated area near St. Louis and Evansville, all the way up to encompass most of Illinois, parts of Indiana, parts of Kentucky, most of southeastern Missouri, including the cities of St. Louis, Springfield, Peoria, and Evansville, and that encompasses a population of 8.5 million, right? 8.25 million. So that's what's going on. The marginal risk includes a lot of metro areas: Chicago, Hannibal, Milwaukee, Fort Wayne. Those storms, probabilistic 15-5. So that's basically what's going on. Let's go ahead and read this. There's not very much to read off of, so this should be quick. There's a slight risk of severe thunderstorms across portions of northeast Arkansas, southeast Missouri, and much of Illinois, western Indiana, and western Kentucky, and extreme northeast Tennessee. Summary: severe thunderstorms are possible on Saturday across portions of the middle Mississippi and lower Ohio valleys. All severe hazards will be possible with these storms. Mid-Mississippi to lower Ohio valleys. Mid to upper level trough over the Central Plains, lower Missouri Valley will develop at northeast across the upper Mississippi, mid to upper Mississippi Valley on Saturday. As this occurs, a strong southwesterly deep layer flow will overspread the region. A plume of steep mid-level lapse rates also will reside over the region at least towards the 0 to 3Z period, which for context, that's basically 7 to 10 p.m. right there in Central Time. So, yeah. Southerly low-level flow ahead of the eastern advancing cold front will transport mainly lower 60s Fahrenheit dew points as far north as southwest Wisconsin and southwest lower Michigan. The temperatures are going to be like 70 degrees. That's already close to 90%, close or at 90% right there of humidity. So please keep that in mind. While weakening as it develops northeast or towards the northern Wisconsin by the end of the period. The cold front will sweep eastward across eastern Missouri and Illinois, becoming positioned from lower Mississippi into western Tennessee, southern Arkansas by Sunday morning. Moderate destabilization ahead of the cold front is expected as some early day clouds and showers should diminish and shift east. Forecast soundings indicate enlarged low-level hydrographs amid 40 to 50 knot effective shear magnitudes, supporting initial supercells across parts of the east central southeast Missouri, northeast Arkansas, and to portions of Illinois. Large hail and a few tornadoes appear possible with this initial activity. With time, some upscale development with QLCS appears likely as deep layer flow becomes unidirectional and a parallel to the cold front. However, speed shear is in the lowest couple of kilometers suggests that multi-vortex development will be possible along the line. If the transition to a QLCS broken line segments occurs, damaging wind threat will also increase, with a couple of tornadoes possible into the evening into nighttime hours across eastern parts of the outlook area. So yeah, this is the situation we have right here. We could see a QLCS, which is the long line of thunderstorms moving through that area, right there. That's why the slight risk and marginal risk are shaped like this. So, yeah, we'll have to keep an eye out for that. So, yeah, again, there's still some uncertainty, so we don't really know all the information. This could expand into a moderate risk if the instability is too big. I want to check the instability in the Midwest for. Actually, I'm gonna use the NAM, and then I'm gonna use the GFS. So this goes on. This is it right here. This is 15Z. As you can see, we could see CAPE values in parts of Illinois and Indiana up to 2,000 in these areas, about 1,000 near St. Louis, 1,000 to 1,500. I want to check the GFS just to kind of look at this. So. The GFS has it at a lesser extent, although more concentrated towards this just south of St. Louis, with some areas cracking 2,000 joules per kilogram down there. Let's use the gem. Okay, let's use. Okay, this is not what I was looking for. All right. Okay, this is what I'm looking for. Perfect. Okay, so this is it right here. We're seeing CAPE values around 2,000 to 3,000 with the GEM PS right here. So, like I said, there is uncertainty with this, and as the models get closer, they'll be more in agreement. So, stay tuned for that. Let's go ahead and go to the day 4 and day 5 outlooks, because day 4 we have that 15% risk in parts of Texas right here, including Lubbock, Midland, Fort Stockton, Albeline. And day 5, including, it now has areas of Oklahoma City. It's kind of expanded a bit to Alabine and Shreveport, as well as a bit north or south towards Waco. Dallas is in the middle smack to this, so if you're in the Dallas area, gotta pay attention to this because, like I said, you're always in these slight to enhanced risk areas right here. I've kind of made a meme out of this in this channel, but it's nothing to kid around with. So, yeah, this is the discussion right here. We'll talk about day 4 and day 5. So, yeah, discussion. Operational and ensemble guidance suggests an active period of severe weather potential is possible during the day 4 through 8 period. The mid to upper level pattern will continue to be progressive during this time, with several shortwave impulses ejecting eastward across the plains into the Midwest. Day 4, which is Sunday, which is the Texas plains. A weak mid-level shortwave impulse is forecast to eject across the southern Rockies into the southern plains on Tuesday. This will provide subtle ascent over a modestly moist, unstable air mass. Forecast guidance indicates quite a bit of mixing across the Texas south plains and Concho Valley vicinity near a surface dry line. This will likely result in higher based convection. Nevertheless, vertical shear will support rotating updrafts and supercells. Steep level lapse rates and elongitated hydrographs will support large hail, while steep low-level lapse rates and relatively dry subcloud layer enhances damaging gust potential. If pockets of stronger boundary layer and moisture persist, some tornado potential is possible, though this remains uncertain. So, basically, we have some uncertainty right here. We do think there's going to be severe weather in this area in this area of Texas right here, if I can get that. But at this point, it's too uncertain to know how much we're going to get. So let's go ahead and go to day 5. A mid-level shortwave trough will spread eastward across the south-central plains on Monday. Guidance varies concerning how far north or south the wave eject, and strongest ascent may be displaced. I think they meant displaced from better low-level moisture and surface boundaries. Nevertheless, the overall pattern appears favorable for severe thunderstorm potential across parts of the southern Oklahoma and northern Texas as a surface low develops eastward from the Texas Panhandle across Oklahoma. Morning showers and thunderstorms may be ongoing across parts of the area, but guidance suggests that this should clear out and allow air mass recovery ahead of the dry line. If this occurs, supercells with a threat for all severe hazards will be possible. A cold front will surge east-southeast during the evening and overnight hours, and additional convection could develop and shift eastward towards the Arcla text overnight. So there is guidance that's there's going to be morning thunderstorms, but after that should clear out, and we could see another band of stuff. Now, depending on how those morning storms are executed, it could bust the entire severe weather event. And what I mean by that is that there's not enough instability in the atmosphere to have severe weather, or it could do the opposite effect, like it did with Birmingham, Tuscaloosa in 2011, And I talked about this more in my documentary. The links to those will be down below. Yeah, it could do the opposite and just wear down the cap to the point where it just completely, when the next round of storms come, it just completely shatters it. So yeah, only time will tell with this. But with that being said, that is going to wrap up this video. I know this is longer than usual. We had a lot of information to cover, as well as some more graphics I wanted to show today. So if you like these longer forms of videos where they're more informative, please comment below. It is much appreciated, as well as like the video, subscribe to the channel if you are new. It helps me out, helps me make more videos like these. It also helps inform more of the public about what's going on with this stuff. And with that being said, guys, have a wonderful day. Stay safe.